Alright, in this video we're going to graph the reciprocal of a quadratic function. So here's the function we're going to graph. F of x equals 1 over x squared minus 4x plus 3. So that is the reciprocal of the quadratic function, um, x squared minus 4x plus 3. So you're going to see that the steps involved in graphing the reciprocal of a quadratic are essentially the same as the ones involved in graphing the reciprocal of a linear. It's just going to be a quadratic function, so a couple of things are going to be a little more complicated with this. So we start with our y-intercept. So step one is our y-intercept. You find that the same way. You set x equal to 0, so you're going to evaluate f of 0. So that's going to be 1 over, the function was x squared, so that would be 0 squared minus 4 times 0 plus 3, which is equal to 1 over 3. So therefore, the y-intercept is 0, 1 over 3. Okay, the second step is to find the x-intercepts. Or sorry, not the x-intercepts, the vertical asymptotes. So our vertical asymptote, and this is very similar. So our function f at x equals 1 over x squared minus 4x plus 3. Same thing's going to happen that happened with the linear. The vertical asymptotes are going to occur whenever this function is undefined, or whenever the denominator, or that quadratic, is equal to 0. So you're just going to take the quadratic, set it equal to 0, so the denominator is equal to 0, and find those x values. So here we'd have to factor. This one does factor nicely, so the two values are x minus 3 and x minus 1. Sometimes this won't factor. So if it doesn't factor, you might have to do something else. You might have to use a quadratic formula, or there might not be any values. So there might not actually be or vertical asymptotes, which creates some challenges. But in this case, there are two vertical asymptotes. So that's a little bit different than with the linear. This time we have two vertical asymptotes. And they are at x equals 1 and x equals 3. Okay. The third step is the same thing that happened with the reciprocal of a linear. We want to figure out where does y equal plus or minus 1. And this is often a little bit more challenging with a quadratic. The same thing will happen though. We'll set y equal to 1, or f at x equal 1. So we'll get 1 equals 1 over x squared minus 4x plus 3. And then to solve that, right, that would be 1 over 1, so take the reciprocal of both sides. We'd have 1 equals x squared minus 4x plus 3. So that would be x squared minus 4x plus 3 minus 1, x squared minus 4x plus 2. Now here I've got a quadratic function which doesn't factor nicely, and that will often happen. If it doesn't factor nicely, well, then you have to go to the quadratic formula. So x would be equal to negative b, which would be 4, plus or minus minus 4 squared, b squared, minus 4 times a, which is 1, times c, which is 2, all divided by 2a, which in this case is 2 times 1. So x is equal to 4 plus or minus the square root of, and that would be 16 minus 4 times 2 is 8, so square root of 8, all divided by 2, which simplifies to 4 plus or minus, it'd be 2 root 2 over 2, which you could reduce to 2 plus or minus root 2. So there's actually 2 points you're going to get from this. Remember, y was equal to 1, so we get 2 points. We get the point 2 plus root 2, 1, and 2 minus root 2, 1. Okay, so that's 2 key points actually. And we can get the same thing if we set the function equal to minus 1. So remember, you do this for 1 and minus 1. For this one, that's a little bit better. We won't have to use a quadratic formula here. So we get plus 1. This will factor as x minus 2 squared. So x minus 2 is equal to 0, so x is equal to 2. So therefore we have the point x is 2, y is minus 1. So we get 3 key points out of this. We get this value where x is minus 1, and we get these 2 points where x was, where y was 1. Now, for graphing purposes, it might help to kind of approximate this with a decimal. That's approximately 3.41, and this one's approximately 0.6. I've rounded, but so remember, the reason that you want these points is to graph them. So if you have them as 2 root 2 or 2 plus root 2, might be a little bit challenging to actually graph that. Okay, so now what we're going to do is go over to the next step. So remember the steps. We just finished the third step. The fourth step was looking at the end behavior. So the end behavior is good for reciprocals because it's always going to be the same. So f at x was equal to 1 over x squared minus 4x plus 3. So we want to figure out what happens as x goes to infinity. And again, think about what's happening to the reciprocal, right, to the p at x. So what happens to the denominator here as x goes to infinity? Well, we know that the denominator would be going to infinity because it's a quadratic. And the end behavior of a quadratic as x goes to infinity is y goes to infinity if the leading coefficient is positive, which it is in this case. So if the denominator here is going to infinity, meaning it's going to a very large number, so like 1,000, 1,000,000, 1,000,000,000, you've got 1 divided by a very large number approaching infinity. So 1 divided by 1,000, 1 divided by 1,000,000. If you put that into a calculator, it's very, very close to 0, meaning y is approaching 0. And as x goes to negative infinity, actually the same thing happens because this quadratic is approaching infinity in both cases. So the end behavior is always going to be y approaches 0, and that's true of every reciprocal function. So therefore, there is a horizontal asymptote of y equals 0. And then the last thing we do, or the second last thing we do before we graph, the last thing we do before we graph is look at positive, negative intervals. So remember that f at x was equal to 1 1 over x squared minus 4x plus 3, or in factored form that was 1 over x minus 3x minus 1. We set up our interval table. So we go from minus infinity, and remember from the previous example with linears, you go to where the vertical asymptotes are, which in this case would be 1, 1 to the next vertical asymptote. There's actually 2, which means we're going to have one more interval, so we have 3 intervals. And then here you're looking at f of x. If you want, you can actually look at it sort of in pieces. Just look at each factor, and then kind of overall what the whole function is. You could just look at the function. Now if I took a number between minus infinity and 1 and subbed it into each of these factors, I would get a negative value. If I took a number between 1 and 3 and subbed it into each of these factors, this one would be positive and this one would be negative. And a number bigger than 3, they would both be positive. So if remember, f of x is the quotient of these two things, or sorry, it's 1 over the product of these two things. So if I multiply these two things together, two negatives make a positive, positive and a negative make a negative, and two positive make a positive. So therefore, f of x is positive if x is in the interval from minus infinity to 1 or 3 to infinity, and f of x is negative if x is in the interval from 1 to 3. So now we're going to take all that and put it together to sketch our graph. So we have to come up with a scale which allows us to graph all the key values. So key values, we had 1 and 3 were important. So now what we're going to do is label our key points, or our vertical asymptotes I'll do first. So this is the point 1. So we had a vertical asymptote at 1. I'll label that x equals 1. Vertical asymptote at 3. X equals 3. Label that. Horizontal asymptote was 0, so that's right along the x-axis. Now I'll put my key points on. So remember we had a y-intercept that was over here. Y-intercept of 0, 1/3. So 0, 1/3, let's say that's 1. So 0, 1/3 would be right around there. And then I had some key points. I had 3.41 and 0.61. So 3.41. So 3.41 would be around there. And 0.61 would be around there. And then I also had this point at -1, 2, -1. So at 2, we had the point -1. So I have those 1, 2, 3 points plus the y-intercept, 4 points. Now I'm just going to connect the points, making sure that my positive negative intervals work out correctly. So remember, those were our positive negative intervals, and I approach the asymptotes in the right way. So if x is less than -1 or less than 1, the function should be positive. So I'm going to connect these points and approach the vertical asymptote, and I have to be positive, meaning I'm going to stay above the x-axis. So it does something like that. Between 1 and 3, f of x was less than 0. I have to hit this point, and I'm going to approach the vertical asymptotes. So it's going to look like this. And if x is bigger than 3, f of x is positive. So it's got to be on the positive side of the x-axis. And it's going to approach the asymptotes, so it'll look something like that. So this is our function f of x. So that's how you graph a quadratic, a reciprocal of a quadratic. And that's all. That's as high as we're going to go. We're not going to do reciprocals of cubics or quartics because if you can do a quadratic, it would be very similar. You just might have more vertical asymptotes for these higher degree ones, but everything else is very similar.